Hi everyone, in this video we will talk about concurrent programming in Golang by me, Radical Rahman Wahid, and my friends, Muhammad Sumana Ali. Okay, uh, the first is, what is the concurrent programming? Concurrent programming is a programming paradigm that deals with the execution of multiple tasks simultaneously. In concurrent programming, tasks are divided into smaller units of execution, which can run independently and concurrently with each other. This is the concurrent process illustration. So we have two tasks on one CPU. Tasks are executed concurrently. For example, task 1 is executed first. When it's waiting for something, the process switches to task 2. Then after task 2 is waiting for something, the process uh, switch back to task 1. This happens until both tasks is finishing their execution. This is the simple process. This is the simple of this is the simple illustration of concurrent processing. So to give you more clear illustration about it, like this. For example, you have two tasks. First, doing your homework and order food, then eat it at the restaurant. Okay, you doing your homework. It consumes 15 minutes. Then order food and eat it at the restaurant. It consume 30 minutes for the total. So the total time to do both tasks sequentially is 45 minutes as well. But when you do both tasks concurrently, the process is different. First, you order the food and it consumes 2 minutes. Then, while waiting the food to serve at you, you do another task, which is doing your homework for 50 minutes. After you finished your homework, then the food is served to you and then you can eat it. You eating the food for 13 minutes and the total time to do the both tasks concurrently is only 30 minutes. The point is, we use waiting time to execute the other task. This is the point of concurrent programming. Okay, how about concurrent programming in Go? Actually, we can apply the concurrency paradigm easily in Go because it's built with built-in support for concurrent programming. Coroutines and channels are two main actors to do it. We use coroutines to implement concurrent tasks. It's lightweight and independently scheduled. Channels are used to communicate between the coroutines or tasks, like data synchronization. Okay, we move to coroutines now. So in Go, concurrent tasks are often implemented using coroutines, which are lightweight, independently scheduled threads of execution. Coroutines are created using the Go keyword, making it easy to launch concurrent tasks. They are similar to threads, but they are managed by the Go runtime instead of the operating system. Okay, let's move to the VS Code. I will explain you more clearly. Okay, in this code we have a function called print numbers. It's actually just printing the number on while loop. Okay, so this is basically how we create the coroutines or performing the concurrent task in Go in a simple way. And then we have another for loop in here. The function is just printing the number, same as the print numbers function. Okay, so but what make it different is here we can know that it is print from coroutine, and this is print for from main actually. Okay, let's do the job. So we need to run this file in order to know what happens inside it. Coroutines. Okay. So it's executing uh, 5 seconds by concurrent programming. How about if we delete the comment here? Let's see what happens. Yeah. So yeah, this is the difference when uh, when we are using the coroutines and not using it. Previously, we are using coroutines to perform concurrent programming. It takes 5 seconds to finish the program, but when we deleted the comment before the print numbers calling function, it just run program. It's just run sequentially in this program, and it took 10 seconds. So by using go in here, we can just make print numbers, and this one, this for loop run concurrently. So if we run it again, it will run not more than 10 seconds for the total printing. So yeah, this is the this is the advantage of using coroutines in co-programming language. Okay, let's move back to the slides. Next, we will talk about channels. Actually, coroutines communicate with each other using channels, which are a way to pass data between concurrent tasks. Channels provide synchronization and communication between coroutines. Okay, let's move to the VS Code again. So this one. So yeah, let me clear this terminal. Okay, actually we have two functions. First, it name producer, and secondly, the name is consumer. Actually, on the producer function, we create data I, and then on the consumer function, we receive the data that has been created by a producer function as well. So there are two functions, and we need to make it communication. We need to make it communicate each other. Okay, actually how to make it is just using channel like this. Make chain integer, and then we just start our coroutine. This is first coroutine producer, and take channel as its parameter, and then we create the second coroutine, which is consumer, that to create and pass the channel as a parameter. This is just to this is the helper code that just so we can just see what happened during the produce and consume data on this code. Let's run the code. Go run channels. Go. Okay. So it's actually on this part we have sending and received. When on the first we we sending data 1 into channel, and then we sending data 2 into channel, and then we receive the data through the channels. It received 1 and 2. It just printed here, right? Like this. Range channel, and then like here. So it's actually I variable is 1, right, on the first iteration, and then I send the data into channel, and when it comes to the consumer, it can take the channel as the parameter, and then assign the number to num variable, and then we can print num variable here. So with this channel and go command, we can do communication between two different coroutines as well. But if we delete the go, it just have a characteristic like ordinary function, so they are unable to communicate as well. So that's why this is throw an error. So if we run it again, okay, this is the result. But we run again. Okay, this is the result. So this is the way how we use channels in Go programming language. Back to the slides. Okay, as I mentioned earlier on the previous videos, I say that concurrent is not the same as parallel, because concurrency allows for efficient utilization of system resources by keeping the CPU busy while other tasks are waiting for I/O operation or other events. To make progress on more than one task concurrently, the CPU switches between the different tasks during execution, like on the previous illustration. But parallel execution is when a computer has more than one CPU core and makes progress on more than one task simultaneously. So each CPU have their own task, while the concurrency only happen in one CPU only. So this is the parallel process illustration. So every task assigned on different CPU as well. Okay, to give you more clear illustration, like this. You have two homework, which is the time to complete it for each is 15 minutes. Then you need to 30 minutes in total to complete all of your homework sequentially. If you do it in parallel, then you need the another person with the same skills as you to do the other homework with you. So the total time to finish all of your homework is only 15 minutes as well. Okay, how about parallel programming in Go? In Go, actually, we don't need to reach the CPU or OS level when we want to implement a parallel programming. We can just use coroutines and channels to run the parallel programming in Go. Okay, let's move to the VS Code again. Okay, this one. Okay, actually, in this code, we will running this program that applied parallel processing. First, we need to define the function. I think this is the function. But okay, we define the function, and it has two parameters. which are named as a string, and task done as a channels that has the string as its data. Okay, first it just print is cooking, and then it's waiting 2 seconds, and then the last one is just to send the data into task done. Okay, this is the chef function. On the main function, we create the two channels or buffer channels, and then it create actually three chef coroutines. And after we create coroutines, we will await the result from our chef. Okay, let's we run the code. Go run multiprocess. Let's go. Okay, so Jonah is cooking, Chef John is cooking. So yeah, this is the how we run program parallelly, right? So if we want to compare the time of execution, we can do it like sequentially, and we need to see it like this. Let's turn this code to sequentially, and then like this, and we need to delete it, and then we just print this thing. Print a line. Okay, name. What is this? Okay, this one. It's not need to. Okay, this is how we run the code sequentially. Okay, we know that we know, right, that the time is waiting 2 seconds, and it can be slow. But if we turn back the code into parallel one, and the time execution will be faster, because there are 3 tasks that being executed parallelly, like this one. Let's run this code again. Okay, finished. So yeah, this is the parallel programming's looks like in Go. Okay. So conclusion. In conclusion, Go provides powerful mechanism for managing concurrent tasks and communication between them. Coroutines offer lightweight concurrency, while channels facilitate communication between concurrent tasks. With its built-in support for concurrency and parallelism, Go empowers developers to create highly efficient and scalable software solutions as well. Okay, this is our reference, and thank you for watching. See you in the next video.